Now coming to the next method for the preparation of hydrogen. Rather it is manufacture of hydrogen, I should say. So the name of the process by which we manufacture hydrogen is your Bosch process. We can say that. It's very important, children. Very important. Bosch process. By this method we prepare what you can say, or rather I should say we manufacture hydrogen. So there are several steps are there which you need to understand there. Step by step I will say. The first step is your preparation of the water gas. What is water gas? Water gas means it's an equal volume of carbon monoxide and hydrogen. Equal volume of carbon monoxide and hydrogen together is called as the water gas. Now how do you prepare it? Now as I said, it's an equal volume of carbon monoxide and hydrogen. What we do is that we take red hot coke, or we can say white hot coke. Means it should be very hot coke, whatever it is. Either you can say red hot or white hot. Generally we take that is white hot coke, because white hot coke is very hot compared to the red hot coke, you can say that. Now through that superheated steam is being passed. Superheated steam. Now what is superheated steam? Now steam means when water is heated at 100 degrees centigrade under normal atmospheric pressure, then it gets converted into water vapor or steam. Alright, what I said, when water is heated at 100 degrees centigrade at normal atmospheric pressure, then beyond 100 degrees centigrade, what happens is that it gets converted into steam. Water gets converted into water vapor or steam. But when you are, that is increasing the, what you can say, pressure, remember it, when you increase the pressure, then what happens is that the temperature of the what you can say, the boiling point of the water also increases. That means now the water boils at 160 to 170 degrees centigrade, and hence again it gets converted into steam. Alright, what I said, when you increase the pressure, so with the increase in pressure, temperature also increases. You have read it in Amundsen's law, the pressure temperature law. So when you increase the pressure, the temperature also increases. Now water, instead of boiling at 100 degrees centigrade, now it will boil at 160 to 170 degrees Celsius. What is that known as? That is called as superheated steam. That is said to be as superheated steam, we can say. Understood what is superheated steam? When water boils under pressure at 160 to 170 degrees centigrade, it again gets converted into steam. That is called as superheated steam. Now what you will do is that you will pass the superheated steam through this white hot coke. You are going to pass it. Clear? So what is going to happen? C plus here water. Now this is your superheated steam, so to say. So what is going to happen? It is going to get converted into water gas, CO plus H2. This is known as water gas. You can see it is equal volume of carbon monoxide and hydrogen. It is equal volume of carbon monoxide and hydrogen. It is being done. So here the temperature is around, we can say, 1100 degrees Celsius. The temperature is 1100 degrees Celsius. We are having the temperature. Here it is. Alright. So what you find is that this particular reaction is also called as syn gas. Syn, S-Y-N, syn. We can also call it as. Syn means synthesis gas. Syn gas or synthesis gas. And the process of producing syngas from coke or coal is called as coal gasification. Again I repeat, the process of producing syngas or synthesis gas from coke or coal is known as coal gasification. We can say that. Now syngas, which is a syngas? Now generally what we used to consider that an equal volume of carbon monoxide and hydrogen is your water gas. Equal volume. See, one volume of carbon monoxide, one volume of hydrogen. It is called as a water gas. We are considering it. Alright. Earlier it was considered that 1:1 mixture of carbon monoxide and water, what you can say, steam is called as a water gas. That is hydrogen, equal volume of carbon monoxide and hydrogen. And how it is being produced? When we pass superheated steam through white hot coke, we get equal volume of carbon monoxide and hydrogen. Fine. Earlier it was considered. But now all mixtures, listen carefully, but now all mixtures of carbon monoxide and hydrogen, irrespective of their composition, is called as syngas or synthesis gas. Now that is any composition, any what you can say proportion of mixture of carbon monoxide and hydrogen, alright, is called as syngas or synthesis gas, we can say that. Alright, the name syngas synthesis gas is derived from the fact that carbon monoxide and that mixture of carbon monoxide and hydrogen, got it, is used for synthesis of methanol and number of hydrocarbons. Later on we'll study in the what you can say, what to say, the properties of hydrogen we will be studying it later on. That is being used to prepare methanol, it is used to prepare what you can say, many hydrocarbons like ethene, acetylene and so many, we can say that, clear. So in this way, from there we have derived the name, that is syngas or synthesis gas, which is because it is used to synthesize so many other organic products, we can say that, clear, understood now. So in this way, so nowadays that is syngas is produced from sewage, got it, sewage, you know, that is nothing but from the drains we are getting it. So from the sawdust, from the scrap wood, from the newspapers, etc. Scrap means the wood which we throw it out, which is unused, we can say that, that is a scrap wood. The sawdust, you know, that the dust which you are getting it after cutting the wood, that is called the sawdust. The newspapers, etc. Nowadays we prepare the syngas or the synthesis gas from this out, we can say that, clear. So in this way what we got is that we got the first step, that is the water gas is being produced. Now after preparing the water gas, what you need to do? You need to pass against what you can say, steam through this water gas. That is, in the second step, you will take the water gas, you took it and you take superheated steam. Now you need to take some conditions here. Here you will be taking, that is catalyst, promoter and a particular temperature you will be mentioning it. Alright, the catalyst is Fe2O3 is a catalyst and Cr2O3 is a promoter. The temperature is 500 degrees Celsius and the pressure is 1 atm pressure, the normal pressure, we can say that. So what I am going to get it? I am going to get it carbon dioxide and hydrogen gas, I am going to get it. See, CO2 plus 2H2, that is, I am going to get it, that is carbon dioxide and hydrogen gas. So what we do generally is that, so we are taking here water gas and twice the volume of steam. Now here for the balancing purposes it is not shown here twice, but generally, practically what we do is that we are taking here, that is, let us say 5 liter of water gas I am taking, so 10 liter of superheated steam I need to take, or more of it. Why? So that the reaction will favor in the forward direction, will go in the forward direction, got it, for that particular reason, so that the reactant is taken is more, we can say that, clear. So passed over a mixture of ferric oxide and chromic oxide, we can say that this acts as a catalyst and this acts as a promoter. Temperature is this much, normal atmospheric pressure, 1 atm means normal atmospheric pressure, what we get, carbon dioxide and hydrogen gas, we get it. Now this particular reaction, this particular step is called as water gas shift reaction, that is known as water gas shift reaction. It's a chemical reaction in which carbon monoxide of the syngas or the synthesis gas, the carbon monoxide, this is also syngas, water gas, that is react with steam to form carbon dioxide and hydrogen, we can say that. Carbon monoxide reacts with the superheated steam to form carbon dioxide and hydrogen gas is produced. So hence this reaction, this step is called as water gas shift reaction. This is said to be as water gas shift reaction, it is known as. In this way hydrogen gas is produced. Now after production of the hydrogen gas, we need to collect the hydrogen gas. What you have to do? First you have to remove the carbon dioxide from the mixture. From the carbon dioxide and hydrogen mixture, you have to remove the carbon dioxide. So hence what we do is that, listen carefully, we pass this mixture means carbon dioxide and hydrogen mixture, alright, carbon dioxide and hydrogen mixture. So we pass this particular mixture, it is being compressed under high pressure and it is being passed through what you can say, water. You know that when this particular carbon dioxide gas is being compressed and it is being passed through water, then the solubility of the carbon dioxide gas in water increases. Got it? Because in cold drinks, what we do? We pass carbon dioxide gas under pressure. So here also same thing we are doing. Here also same thing we are doing. Under pressure we are passing the mixture in which carbon dioxide will dissolve in it, but hydrogen will not dissolve because hydrogen is practically insoluble in water. Practically, we will see that it is insoluble in water. But under pressure, carbon dioxide is going to dissolve. Alright. So carbon dioxide dissolves completely in water. But due to this reason, what happens is that hydrogen becomes moist. Alright. So reaction what it takes place, CO2 plus water under pressure. So pressure is 25 to 30 atm pressure. Very high pressure is used to form what? Carbonic acid. This CO2 reacts with water under high pressure to give carbonic acid, H2CO3. It is being formed. We can say that carbonic acid is being formed. Now the hydrogen as a result becomes moist. So hence what we do is that before collecting the hydrogen gas, we need to dry the hydrogen gas. We need to dry it out. Alright, but here along with it carbon dioxide, there may be chance of carbon monoxide also may be present. Unreacted carbon monoxide, because carbon monoxide reacts with this oxygen of the steam to form carbon dioxide. So there might be some unreacted carbon monoxide might be present. Unreacted carbon monoxide. Again I repeat. So for that reason, what we need to do is that we first pass it, after passing through water that is under high pressure where carbon dioxide is completely dissolved, we are passing through ammoniacal cuprous chloride solution. The next step is ammoniacal cuprous chloride solution. Now ammoniacal cuprous chloride solution is a solvent for dissolving carbon monoxide gas. It dissolves carbon monoxide gas. It absorbs carbon monoxide gas. What I said? Ammoniacal cuprous chloride solution. We can say that. And ammoniacal means NH4OH plus Cu2Cl2. That is said to be as ammoniacal cuprous chloride solution. We can say that. So we are passing it, this mixture, this gas again we are passing this after passing through water, we pass the mixture again through ammoniacal cuprous chloride solution, so that if at all any carbon monoxide unreacted is there, it will dissolve in it. Done. Over. Now next is to remove the moisture. As I said you, the hydrogen gas becomes moist. To remove the moisture, what we do is that we pass it through that is a pipe. Alright, we pass it through a pipe or we pass it through a tube which is being cooled to a temperature of minus 25 degrees Celsius. We can say that, which is being cooled minus 20 to minus 25 degrees Celsius. It is being cooled. Why? Because when we'll pass this gas, now first we have removed carbon dioxide, done. Then we removed carbon monoxide, done. Then we want to remove the moisture, because I want to collect the dry hydrogen gas. So what I need to do is that you pass it through the pipe which is being cooled to a temperature of minus 20 degree to minus 25 degrees Celsius. Alright, that means the pipe is being covered with ice jacket. We can say that. Clear? Now ice will give a temperature of 0 degree centigrade. It's not only ice, it is called as nothing but a freezing mixture, a mixture of common salt and ice. Alright, which will give a very low temperature. Or we can also lower the temperature, we can say that. Alright, we can mechanically also we can lower the temperature, we can say that. So in this way, what will happen there? That is, the moisture will convert it into ice. Whatever the moisture is present in the hydrogen gas now, because hydrogen gas becomes moist. So whatever the moisture is being present in the hydrogen gas, when you pass it through the pipe, so that moisture now turn into ice. The water now turn into ice. Now hydrogen gas passes through the pipe. Got it? We can say that it passes through the pipe, we can say, where water freezes, the moisture freezes. Now the gas is further passed through, that is fused calcium chloride, anhydrous calcium chloride is being passed, because anhydrous calcium chloride again acts as a drying agent, we can say that. Suppose some moisture still it remains with water, alright, or with water, what I am saying, with hydrogen. Suppose still some moisture remains with hydrogen. So if you pass through a tower which is being packed with anhydrous calcium chloride, what will happen is that it will absorb that particular moisture and it will ultimately, hydrogen gas will be dried, and that hydrogen you collect it by over mercury. We collect it over mercury, or we can collect it by the downward displacement of what you can say air, we can say that. Because hydrogen is lighter, it will go up, and air is heavier, it is going to come down. So the downward displacement of air, we can collect it. Alright, but initially few bubbles is not collected because it forms an explosive mixture with air. After that, hydrogen gas is being collected, we can say that, in steel cylinders. Either you collect it over mercury, we can say that, or you collect it by the downward displacement of air. In this way, hydrogen is being manufactured and collected by Bosch process, we can say that. By the Bosch process, we can, that is, collect and manufacture. That is, first you manufacture, then you collect hydrogen gas in steel cylinders. Okay, so next, after that, we will come to manufacture hydrogen from what you can say natural gas, from natural gas. Now natural gas means what? Natural gas means with the gas which is obtained from the petroleum well, we can say that, which consists mainly of methane gas. Alright, the natural gas means the gas which you are getting from the petroleum well, we can say that, which consists mainly of the methane, CH4, we can say that. Now what we do is that methane, it is being mixed with steam, we can say, under high pressure, that is a pressure of 30 atm pressure, we can say that. This is natural gas that is being passed over, that is steam under high pressure over heated nickel, which acts as a catalyst. Got it? That is, nickel here acts as a catalyst. So you can take Ni, which acts as a catalyst, and the temperature is a very high temperature. It is being maintained, that is around 800 degrees Celsius temperature is being maintained here. Got it? 800 degrees Celsius. So what is going to happen? Here I am going to get, that is nothing but hydrogen gas. I am going to get it first of all. Now what more I am going to get it? I am going to get it nothing but carbon monoxide, CO, isn't it? You can see here C and O, it will give you what? CO. And here, for how many hydrogen is there? 6 hydrogen total. 4 plus 2, 6. I will be getting 3H2. And here I will be getting carbon monoxide. So you may say this is also a syn gas. You can say definitely it is a syn gas also, definitely, no doubt about it. Because syn gas, I said any ratio, any mixture, we can say that. So now what we are doing is that how we separate this carbon monoxide and hydrogen. Just now we studied in the Bosch process. You will pass it through anhydrous, ammoniacal cuprous chloride solution. You pass it through. When you pass it through ammoniacal cuprous chloride solution, carbon monoxide will be absorbed in it, because that's a solvent for carbon monoxide, and hydrogen will be set free. After that, hydrogen, you know how to collect it. You pass it through anhydrous calcium chloride, a tower which is being packed with anhydrous calcium chloride, and you collect the pure and dry hydrogen. In this way, we can also prepare hydrogen from natural gas. We can say that. Got it? We are taking the natural gas and you are passing it through. This is your steam, mind it. This is water, means this is your steam. Again, same thing. The steam under very high pressure and in presence of nickel as a catalyst and 800 degrees centigrade temperature, very high temperature also, we are getting, that is hydrogen and carbon monoxide. Again, you can say it's the same gas. How to remove carbon monoxide? You have already studied that. You just pass it through what you can say ammoniacal cuprous chloride, where carbon monoxide will be removed and hydrogen gas will be what you can say collected by the downward displacement of that is air, or it is being collected by the help of mercury, as I said. We can say that. Clear? In this way, the pure and dry hydrogen, we are collecting it. Now we can take any other hydrocarbon here, that is we have taken methane here. We can take any other like ethane, propane, anything. You will be taking it. So you will be getting hydrogen and the carbon monoxide gas will be getting it, and you will be collecting the hydrogen gas in that manner. As I said, you will be collecting it, the hydrogen gas. Got it? Are you following what I am saying? You can take here any other means, suppose I am taking here, let us say C2H6 plus water. This is known as what? This is methane. This is called as ethane. Let me write the name also here. This is methane and this is ethane. Same conditions, under same conditions. So what I am going to get? I am going to get carbon monoxide. See here, carbon monoxide. Got it? Plus here, that is nothing but I am going to get it, that is a hydrogen gas. Now here 2 carbon is there, so to balance it I have to take 2 water here. So I will be getting 2CO. Now how many hydrogen here? 4 hydrogen plus 6, 10 hydrogen. So I will be getting here 5H2. Balanced. In this way. Any other, you can take methane, ethane, propane. In this way, any other you can take it. That is hydrocarbons. And correspondingly, you will be getting the nothing but the carbon monoxide and hydrogen gas. You will be getting it. Clear? In this way, this process can also be used for the preparation of what you can say hydrogen. That is from the natural gas. We can also prepare, that is hydrogen, so to say. Now, next is this particular process for the preparation of from the steam. That is a natural gas. This also is a steam. Mind it. I forgot to write here. This is a steam. This one. Clear? This particular process is called as nothing but steam reforming process. This is also called a steam reforming process. That is the process of obtaining that is hydrogen gas from the syn gas by passing it through steam is called the steam reforming process. We can say the whole process obtained from that is from natural gas to prepare hydrogen is called as, again let me repeat, that is called a steam reforming process. We can say that. Now we can also prepare it by simply cracking. Cracking means what? Pyrolysis. Pyrolysis means heating of the alkenes in absence of air or limited supply of air. That is called as pyrolysis or cracking. We can say that. Heating of the alkenes. This is alkenes. Methane, ethane. These are alkenes. We can say that. Heating of the alkenes in absence of air or limited supply of air is otherwise known as pyrolysis. Pyrolysis. Pyrolysis or cracking. Alright, again I repeat, heating of the alkenes, methane, ethane, propane, butane, these organic compounds are called as alkanes. Heating of the alkanes in absence of air or limited supply of air is known as pyrolysis or cracking, we can say that. Clear? Now what I am going to do, see here, CH4 I am going to heat it. No oxygen, nothing, because I said you, absence of air. Alright, so in presence of 1270 Kelvin and any catalyst I can use it, like I can use nickel, I can use platinum, palladium, chromium, in this way I can use as a catalyst. So what I will be getting? I will be getting carbon plus hydrogen, Cl, C plus 2H2 I will be getting it. So this process is called as cracking of, that is nothing but the, which gas? Natural gas or petroleum, we can say that. Clear? We can prepare hydrogen. Now, we can also prepare it from Lane's process. Lane, L-A-N-E apostrophe S, we can say that. L-A-N-E'(S), Lane's process. In Lane's process, what we do? Same thing. We are passing steam over iron, red hot iron. We are passing it. Steam. The temperature is around here 1023 to 1073 Kelvin. So when we pass, this is your steam. Understood? So when we are passing it through iron, what I am going to get it? That is nothing but I am going to get magnetic oxide of iron, Fe3O4, and hydrogen gas. And the reaction is highly exothermic in nature. Large amount of heat is being evolved. It is an exothermic reaction. Large amount of heat is evolved. Fe3O4 and hydrogen gas we are getting it. This is called Lane's process. So superheated steam, this is also same thing. Superheated steam. Mind you, when I say steam here in Lane's process or the natural gas or in the Bosch process, I have told you already that is superheated steam. Alright, so superheated steam is passed over that is hot iron fillings. We can say that this is iron fillings. The temperature is maintained around this. So what I am going to get it? I am going to get magnetic oxide of iron, Fe3O4. This is said to be as triferric tetroxide and magnetic oxide of iron and hydrogen gas is being released. Now, next is what I need to do is that I need to again get back that is Fe3O4. Now hydrogen, how you that is collected? I have already said you how to collect it. We will first pass it through anhydrous calcium chloride to ensure that if any moisture will be present. Here of course moisture I can't see, but maybe some what you can say steam can stick to hydrogen gas. Alright. So to ensure that no moisture is there, what we do is that we pass it through anhydrous calcium chloride. Alright, a tower which is being packed with anhydrous calcium chloride, or you can pass it through pipe, we can say that, which is cooled to a temperature of -20 to -25 degrees Celsius, where my moisture will be turning into ice in that particular pipe, we can say that, if at all any moisture will be there, that will turn into ice. Alright, and hydrogen gas is being collected by over mercury or by downward displacement of air, we can say that. Clear? Now, the most important here, this is your oxidation step. In the Lane's process, the first step is your oxidation. In the oxidation step, iron is being oxidized to Fe3O4. Alright? Clear? Now, second step is the reduction. Reduction means I have to reduce Fe3O4. So, hence, I will pass a mixture of hydrogen and carbon monoxide. That is a mixture of water gas through Fe3O4. After collecting hydrogen, I will pass water gas through Fe3O4 through magnetic oxide of iron. What I said? Water gas. Water gas means a mixture of hydrogen and carbon monoxide. Now both here, hydrogen and carbon monoxide acts as a reducing agent. It reduces, that is Fe3O4 to again Fe. Got it? See, if I take here hydrogen, got it? What will I get it? I will be getting, that is nothing but 3Fe plus 4H2O. We can say that. Clear? And if I take carbon monoxide, Fe3O4 plus CO, I will be getting same thing, Fe plus CO2. We can say that. So that is of course here 3Fe is there, and here there is 5, that is oxygen is there. So how many you require it? There is nothing but here I will be taking here 4 CO. So it will be 4 CO2. So 4 to the 8. Here it is nothing but 4 oxygen plus 4 oxygen, it is 8 oxygen. Alright, in this way it is being balanced. So this 2 step is called as a reduction, and this step is called as a oxidation. In the first step, in the oxidation step, we get hydrogen, and in the reduction step, we get back again iron. Again, iron further react with steam to produce again Fe3O4 and H2. So in this way, the cycle goes on. First oxidation, reduction, again oxidation, reduction. In this way, we are producing what you can say that is a hydrogen. That is by Lane's process, we are manufacturing hydrogen. We can say that. Thank you.